This video is on the concentration of a solution, and mathematically, how do we represent that? So if we're talking about how concentrated a solution is, what we're talking about is how much stuff is in it. Now, the type of solutions that we're dealing with here are aqueous solutions. So water is our solvent. And if we add a whole lot of water to a solution, we say we dilute it down. And that means we have less stuff and more water. But if we have a concentrated solution, we've taken some of the water out, so we have a lot of stuff in it, or that means a high amount of solute. So concentration refers to how much solute is in a particular solution. One of the most important calculations you will learn is how to represent the concentration of a solution in molarity. And that's the one we're going to talk about here. As a chemist, I use molarity all the time. There are other ways to express concentration that you learn about in other chemistry classes, but by far, molarity is the most common. So molarity is represented by a big M. And if you're trying to think about it, well, it's molarity. What does it probably have in it? Moles. And it does. So molarity is the moles of the solute divided by the liters of solution. So it expresses how much stuff is in there. Now, if we're talking about different types of solutions, a high molarity would be something like 12 or 18. Those are really, really high molarities. And we would say those solutions are very concentrated. A low molarity, like 1 molarity, is a pretty dilute solution. So it doesn't have a lot of stuff or a lot of solute in there. Now, this equation is pretty easy to work with, but again, it is very unit specific. And we can, just like we did with density, use the little triangle trick to help us rearrange this particular formula. Remember, the amount of your solute has to be in moles, and the amount of your solution has to be in liters. If those aren't in the correct units, you're not going to be calculating molarity correctly. So I have an example problem that we can work with. And in this one, it says, what is the molarity of a solution composed of 20 grams of sodium hydroxide dissolved in enough water to make 2 liters of solution? So if we start with the little triangle trick, just to remind you on how that works out, we have M, these are our moles of solute, and these are our liters of solution. So in this case, we're looking for our molarity, so it's moles divided by liters. Molarity equals moles of my solute divided by liters of solution. All right, so now your solute is the substance that we are dissolving. And in this particular one, we are dissolving sodium hydroxide. So the amount of sodium hydroxide that I have here in this solution needs to be expressed in moles before I can plug it into this equation. Well, they're telling me that I put 20 grams of sodium hydroxide in, so that's how much solute I have. And now I'm going to convert it to grams, from grams to moles. So I need to get the molar mass of sodium hydroxide. We have sodium, we have 1 hydrogen, and we have 1 oxygen. So I add all that up together, and the molar mass of sodium hydroxide is 40 grams per mole. Okay, so that means the moles of solute are 0.5. Now, my liters solution, they actually give me in the problem as 2 liters. Now, you've had enough experience with me and know that Tricky Miss Zalewski will often give you things in milliliters just to kind of throw you off, to make sure that you understand that the amount of the solution has to be in liters. Here it is in liters already. And so we can calculate our answer. This is going to be 0.250. And the units for molarity is a big M, And the way we pronounce it is molar. So we would say the solution is 0.250 molar, like the tooth, molar. All right. Pretty straightforward. Again, you just have to be very conscious of what units everything needs to be in. Now, this is all well and good, and we can calculate the molarity of a solution. But oftentimes, what I would do as a chemist is I have to figure out how much solute I need to make a certain molarity solution. So I have an example problem for that. And this is how many grams of sodium chloride are present in 600 milliliters of 1.55 molar NaCl solution. So in that, how many grams of NaCl? NaCl is what I'm dissolving. So I'm asking for the amount of solute. The only thing that has solute in here are moles. So my answers in dealing with the molarity problem is going to come out in moles, and then I just have to convert it to grams. So for this one, I'm going to again draw my triangle here. Oops. Bigger this time. Okay, so I'm going to rearrange my equation first. They're asking me about the amount of solute. So I cover up moles of solute, and it's molarity times liters. So if they're beside each other, it is multiplication. If they're over one another, it would be division. So what this is telling me is that moles of solute is equal to molarity times liters. All right. Well, they give me the liters. Oh, they don't give me the liters. They give me 600 milliliters. So to go back, King Henry's daughter bakes delicious chocolate muffins. I'm at milli, and I need to go back to a base unit. So 1, 2, 3 in that direction. So 600 milliliters. 1, 2, 3. So that's going to be 0.6 liters. All right, and they give me the molarity of 1.55. So I'm going to say 1.55 molar times 0.600 liters is going to give me my moles of solute. And then 1.55 times 0.6 is 0.93. I guess 0 to keep the number of sig figs correct. This is how many moles of my solute, and my solute is NaCl. Okay, we're almost there, but they didn't ask for moles, they asked for grams. But that's easy. We can go from moles to grams using molar mass. So 0.930 moles NaCl. And then I need to get the molar mass using the periodic table. Here is sodium, has 22.99, chlorine, which is 35.45. So 35.45 plus 22.99, and I get 58.44. That's how many grams are in 1 mole. Mole is here, mole has to go here, and in 1 mole, there are 58.44 grams of NaCl. And then I just everything on top multiplied together, divided by everything on the bottom multiplied together. And I end up with 5.43 grams of sodium chloride. So this would be my answer. And what I could then do is I would measure out 5.43 grams of sodium chloride, and I would dissolve it in 600 milliliters or 0.6 liters of water. And I would have a solution that had the molarity I desired, that 1.55 moles. So if it's asking you about grams, you're having to solve for your solute, and you're going to have to solve for moles first and then convert your moles to grams. If they're asking for molarity, then you'll probably have grams, which you'll have to convert to moles, and then divide by your liters. Watch out. Remember, this thing is very unit specific. This formula is given to you, not the triangle, but the formula, on your formulas page on your reference table. You can see it right here. Molarity is moles of solute over liters of solution. So you don't have to worry about remembering it, but you do have to remember how did you draw the triangle if you want to use that, or how to rearrange a formula. Okay. Now, sometimes I don't have a solid form of a particular chemical, like for acids, that they aren't sold as solids. So what I'm going to have to do is I have to do a dilution. I buy really concentrated acids, and then I make a dilution. So the most concentrated hydrochloric acid I have is 12 molar. But I would never ever give my students 12 molar hydrochloric acid. You spill that on your hand and it's going to eat right through your hand, painfully so. So I need to dilute that down with water to make it not as concentrated and make it safe for what our purposes are here in this classroom. So for a dilution, we use a slightly different kind of formula. And we're going to use this one right here is the one I like to work with. This is the one that's printed in your reference tables. And you can use it, but I think the ones and twos kind of don't lend themselves, as I use C's and D's. So this stands for concentrated. Now, for this one, it's going to be, you have to figure out which one is your concentrated solution and which one is your dilute solution. The lower the number, the more dilute. The higher the number for molarity, the more concentrated it is, the more moles of solute it has. So we look at our molarities here, and I have 0.5 molar HCl solution, and I have a 0.1 molar HCl solution. So the higher number, this one, is going to be my concentrated solution. So the way this problem reads, I'm going to go ahead and write down what I already know. So my concentrated solution is going to be the 0.500 molar. And they want to know how many milliliters of it. So I'm looking for my concentrated volume. And it says, would you need to dilute to make my dilute solution is the one with the lower molarity, and that's this one. And then I need to make 100 milliliters of that dilute solution, so this one is 100. So when you are pulling these numbers out of the word problem, you're going to start with your molarities. So you can decide your concentrated and your dilute. The higher the number for molarity, the more concentrated it is. So your the higher number is going to be MC, and your lower number is going to be MD. Then you have to read the context of the problem to see which volumes you're working with. Oftentimes, you are trying to figure out how much of this concentrated you need to add to get this volume of your dilute, but you just need to read. All right, so for this one, I have MC VC equals MD VD. And in this particular problem, I am solving for VC. So I need to divide both sides by MC. So my concentrated volume would equal to my dilute molarity times my dilute volume over my concentrated molarity. Now I just need to plug in my numbers. So this is going to be 0.100 times 100 milliliters divided by 0.500. Molarity cancels out. All I'm left with are milliliters, and that makes sense for volume. And then 0.1 times 100 divided by 0.5 is going to give me 20 milliliters. So What this is saying is that I need to take 20 milliliters of my zero point 0.5 stock solution or concentrated solution, and I am going to have a flask that holds 100 milliliters. I'm going to add some water in there because this is an acid. And then I'm going to put 20 milliliters of my concentrated solution in there, and then I can fill it up to a total volume of 100 milliliters. So that's how dilutions work. And really, that's when I don't have a solid of something.